All right, section of notes is 6.3. This is HL triangle congruence. This is the last section in module 6. We'll be taking our test after this. So some things we need to recall first. Our last triangle congruence only deals with specifically right triangles. So some things to recall is the diagonal distance or the length across the right angle is called the hypotenuse. This is also known as the longest side. The other two sides are called the legs. All right, so we have two legs here, and these sides are adjacent to it. Other things we need to recall is the triangle congruence theorems that we've learned so far. We've learned about ASA, SAS, SSS, and the most recent one, AAS. This combined with HL are really the 5 triangle congruence theorems that we're going to learn this year. So when you're trying to identify whether triangles are congruent, we look at those criteria. So let's go and put it properly in our notes. What is the HL triangle congruence theorem? It's an if and then statement. If two right triangles have the same, we're going to say hypotenuse and leg lengths, then the triangles are congruent. Okay, that's all it says. So, right, we see, let's say I have a triangle here, right? We've got the same base leg and also the hypotenuse that are congruent. We have enough information to say that they are congruent. Even though we're not really making an argument for like the angle at all. It's just, we're just looking at those two side lengths, but we had to make sure that it's under the umbrella of a right triangle. All right, so we're going to look at this of proving the hypotenuse leg triangle congruence theorem. So we have two right triangles here. If you want to color code, you can, but we're saying that these two are right triangles. We know a couple of things. So we have AB is congruent to DE, so that is the hypotenuse here. And then BC right here is congruent to EF. So we're going to have the tick marks, 1 and 2 tick marks there. We're trying to prove why are these two things congruent. So we're going to prove this using the Pythagorean theorem, understanding that yes, we have a squared plus b squared equals to c squared, noted in red here. We're also going to put an argument for this second one. This is d squared plus e squared, and we already have f squared. So we know that these two things are equivalent. So with this, we know that AB is equal to DE, which is C and F. So these are just the hypotenuse. What it's saying here is, yeah, they're still equivalent. So if we put C squared is the same thing as F squared. So in this, if I know that these two things are equal, so let me actually circle here. This is equal to C squared. This is equal to F squared. Since we know that those two things are equivalent, we can say that those things that I circled are equal to each other. So we have a squared plus b squared is equal to d squared plus e squared. It is given that we already have this. BC is equal to EF, or just A is equal to D, so we know that to be true. We're going to substitute A for D in the above equation, so just put A right here, because we know that it's equivalent to this. Okay, so we're going to have A squared plus B squared is equal to A squared plus E squared. So this equation, it looks alike because what we're going to do is we're going to subtract A squared. And if I do that here, we're going to be left with the equation B squared equal to E squared. All right. And then by taking the square root of both sides, right, if I take the square root of well, I guess I'll just put the square root here. Right, squares undo square roots. We just really have B is equal to E. So in the diagram, we can say B right here is equal to E right here. Yep. Or we can say AC, which is, we'll put this in purple, is this dimension that is equal to DF or FE. I'll put DF. So the triangles are congruent because we have 1 tick mark, 2 tick marks, 3 tick marks, all on the sides. So the triangles are congruent because of SSS, triangle congruence theorem. All right. So we've proven why HL does result in a congruent triangle or 2 congruent triangles. We did that using the Pythagorean theorem. We performed some algebra, and we used one of our prior understandings that SSS is a reason for triangle congruence. All right, let's go to this last one, or this next one. It says your turn. So I'd like for you to prove it. It's not a 2-column proof, but how can you determine these 2 triangles are congruent? So at this point, I'd like for you to pause the video. I'd like for you to identify why are these 2 things congruent? Because we're going through HL triangle congruence, where's the hypotenuse? Where's the leg that are congruent? Pause it, and then once you think you figured it out, I'd like for you to resume it. So figure it out in pencil. Maybe what I write right now is going to be in pen. Okay, I'm gonna give you 3 seconds. All right, so determine whether there is enough information to prove the triangles are congruent and explain. There is enough information, so I'm gonna put yes. So we're gonna put triangle, let's go with VWX, and triangle YXW, well, I should say share a hypotenuse. Right, we see that here, and I know a lot of you, when you look at this, you can already identify that. Why is this congruent? Or sorry, that they share. Well, what thing can we determine from that is that WX is congruent to WX, right? Because it's the same thing, so we're gonna say by reflexive property. Or sorry, did I say reflective? Reflexive. Okay. And also what is given to us is the tick marks here, that we have this is congruent to this. So we also have WV is congruent to Y. Yeah, I should probably put XY. I'll put, well, XY or YX. And it is given. So if this thing is talking about the hypotenuse and this thing is talking about the leg, we can therefore conclude triangle VWX is congruent to triangle YXW by HL triangle congruence theorem. Okay. All right. So if you were to trace it with patty paper, you would have that it is equivalent. So I'd like for you to turn this over to the back side for a proof or 2 proofs. 1 proof already given to us. We're just going to talk about it. And then 2nd proof, we're determining the reasons. All right. So all in all, we're now applying the HL triangle congruence. How can we tell that they are congruent? So for this first one, we're just going to annotate / refer to various things. So we have that P and R are right angles. Okay, note it there. PS is congruent to RQ right there. So I'm just gonna, you don't have to, but I'm gonna highlight this. All right, so we have, yes, it's given. This is also given. So this right here, I'm just gonna put that this deals with one of the legs or each of the legs of the right triangles. We also have now SQ is congruent to SQ, just like the last one. This is the reflexive property where we have, we can think of conjoined triangles there, and that deals with the hypotenuse. And because we have an H, we have an L, we can already identify, yeah, the triangles are congruent because of HL triangle congruence theorem. And that is it. That's got to be the fastest proof we've ever had. And now to round it out, we're like at the 10-minute mark. Or try to figure this out, right? I think for me to give you an answer isn't as educational as you trying to figure it out and then getting some feedback. But yeah, as much as we go through a proof, trying to make sure that we're annotating this. So we have JL are right angles, yes and yes. K is the midpoint of JL, this one here, and MN, this one here. Okay, we're gonna prove that the triangles are congruent. So here we already know that the first thing is given. That K is the midpoint, yep, that's also given. But that gives us so much information because we can conclude that JK, so I'll put this down here, this line segment is congruent to this line segment. And also MK right here is congruent to NK right here. So we already have them listed here and here. And this is, or how do we know that they're congruent? You should hopefully figure out that it is definition of, fill in the blank, it is midpoint. Definition of midpoint. So looking at this, we have, this is the hypotenuse of this first triangle. This is the hypotenuse of the second triangle. This is the leg because it's adjacent to the right angle. And this is also a leg. So, right, the purples are the hypotenuse, the blues are the legs. So therefore we can conclude, yeah, the triangles are congruent because of HL triangle congruence theorem. All right, we're gonna call it there. But yeah, I think we'll probably do some whiteboard practice and then our assignment. Let me know if you have any questions.